Hey everybody, it's Mr. Carr again. Today we're going to be starting Unit 3. It's all about functions. So when we talk about functions, it's a very specific way to compare two things. We'll be going in more in depth into specific types of functions throughout the year. For now, we're going to go over some vocab that's related to it. So today we're going to do 3A, relation versus function. So let's define those things real quick. So a relation is just a mapping of two sets of numbers. And I'll be honest, even though it says numbers, it's honestly just two sets of objects. Because we can actually create relations with things that are not numbers. So objects would be better to put here. So in a function, we talk about, we call it input. Each input value has exactly one output value. Okay, so the idea is this: we take an input value and it turns into an output. Okay, so it's a connection between the two. Domain. So this word means it's a list of all possible input values. Okay. The range is a list of all the possible output values. Okay. So we'll get more specific into domain and range as we work through here. Vertical line test. This is a special test that can help us on a graph. So if you draw a vertical line through a graph, if it intersects more than once, the graph does not represent the function. Okay, you'll see that when we go into more of the test when we show some graphs on here. Okay, different ways to represent our relations. We can do it as ordered pairs. Okay, so it's just, X and Y values, that's all. So one thing to mention about this is typically when you have an X and Y value, this is going to be the input, this will be the output. When I make my table, like I can do X and Y like this. Okay, and I don't know, 2, 3, 7, 9, and then we'll say 4, 5, 6, 7. Okay, so these are my inputs. These are my outputs. Okay, graphing it, we can just put those ordered pairs like as points on there, or you can draw it as a line. Okay, so again, X is my input, Y is my output. The last one is a mapping diagram. And I'm going to use the numbers from our ordered pairs as an example. So what I'm going to do is I'm going to put my inputs in like a box or oval on the left side. So this will be input. Oops. This will be the input, and then this will be the output. Okay, so if I look at my numbers, for my inputs, I have 1, -2, and 0. So I'll go -2, 0, 1. For my outputs, I have 2, 4, -3. So I'll go -3, 2, and 4. So the mapping diagram is just going to draw the connection between the two. So for example, X is -2 goes to 4. So -2 draws down to 4. 0 goes to -3. Whoops, didn't want that. 0 goes to -3. And then the last one goes to 2. Okay. So that's our setup for our mapping diagram, like we're connecting it. Okay, so all of these ways of showing it is trying to demonstrate that there's a connection between the input and the output. It just does it in a variety of ways. So we got to go back to the definition of, for it to be a function, it has to have exactly one output for every input. Okay. The above example. So we look at the order pairs, I guess that's kind of goofy on that one. But we look at all of our inputs here. 1, -2, 0. Do they go to only one value? Yes, 1 goes to 2, -2 to 4, 0 to -3. So in the order pair, yes, it is a function. And if I write the rest of the definition, I would say because every input has only one output. Okay, we look at the mapping diagram for part B. Okay, this one is a no. Okay, the reason why it's a no is because -8 here is going to two different outputs. So if I take my input and I split it up into two different outputs, that's no good. Okay, so no, -8 has two outputs. So that's no longer a function. Okay. And number or letter C. Okay, so look at all my inputs. I got 0, 2, 5, 8, 9. The numbers they go to is 1, 3, 0, 7, 4. So yes, every input has only one output. Okay, so the next part of this said, find the domain and range. So remember when I said earlier, domain is the set of all the inputs, range is the set of all the outputs. So there's a way to showing this. We're going to use what's called set notation here. Okay, so in this first example, my inputs, remember, are right here, -1, or sorry, 1, -2, 0. So I'm going to use braces. Braces in math are used to say a set of things. Okay, I also like to call them fancy brackets because they look pretty fancy, in my opinion. Okay, so we're going to put all the input values, just list them out. So in this case, it was, and the order doesn't really matter, but 1, -2, and 0. Some people like to put them in order from lowest to highest. It doesn't matter. So my domain here is just these numbers listed. That's it. For range, I'm going to do the same thing, but I'm going to do all the Y values, all my outputs. So in this case, it was 2, 4, and -3. Okay. All right. The other function I have is C, so I'll do the domain and range here as well. So domain, I'm just going to list out all the X values. 0, 2, 5, 8, 9. For the range, I'm going to do 1, 3, 0, 7, and 4. Okay. All right. So I'm going to let you try some you try now problems. You know what? I'm going to go ahead. Let me talk about two of them. Yeah, I'm going to talk about two of them because in number 1, okay, this is where the vertical line test comes in. Might as well show it because we didn't do an example of that together. So you try now the first one. To determine if this graph represents a relation or just it is a relation, but to determine if it's a function, we do what's called the vertical line test. And there's two places where I can do that and it doesn't work. So you look here, it hits it twice here, also hits twice here. There's 2 times that it fails. Okay. So a vertical line cannot do that. Like I would have to do something like this. I'll show it a different way. I like to show it here. So here's my vertical line. Okay. And what happens is as I drag across, boom, right there, I hit the 2 points. Not a function. I do it again here, but the first time is all that matters. Even though it does it twice, all I care about is the first one. Okay. So I'm dragging this across. If I ever hit more than 1 point, it's not a function. Okay. So that's why I can say not a function. The other thing I want to mention is look at number 4 here. Okay. Oh, we're frozen here. There we go. We're back. Okay. So we look at number 4. This is a weird scenario where -2 goes to 1 and also 2 go to 1. Remember the definition. Every input has one output. So if I focus on -2, how many arrows does that draw? It only draws 1 arrow. 0, only 1 arrow. 2, only 1 arrow. So this is still a function. Yes, it's a function. Okay. Again, every input only has 1 output. Now, it's okay for me to repeat that output. 2 different values of X or 2 different inputs can go to the same output. That's fine. When I list that for my domain and range, so I got -2, 0, and 2, but for my range, I don't have to write 1 twice. I'll just write it 1 and -1. That's it. Okay, so it's one of those things where repeating outputs, totally fine. But if I look earlier and I repeat my inputs like I did here, no good. All right, so that's it for today. Again, goal today is when we look at a relation, it's a comparison, it's a mapping of 2 items, 2 sets of things. So when we look at our numbers, to be a function, every input can only have 1 output. Okay, all right, that's it for 3A. Take care, everybody. Talk to you later.